Hey guys, this is your notes for what is matter made of. And so on these notes, you're going to see that there is a lot of words. You do not need to write them all down. You only need to write down what I have highlighted in yellow. So please make sure you only write what is highlighted in yellow. And yes, please add it to your notes. So go ahead and title your notes right here, What is matter? And you can see the matter is anything that takes up space and has mass. So just think of anything that you can hold in your hands, like your phone, for example. All right, it takes up space and it has a certain amount of mass. All right, so anything that has mass and takes up space is considered matter. Here's some examples that you should write down. Some examples of matter would be things like steel, water, wood, and plastic. And of course, these are easily visible. Like you can see those right there in front of you. But then there's some others that are not so easily visible. And that would be things like air or dust. And those examples are examples of things that are like impossible to see. All right. So whenever we talk about matter is ultimately made up of atoms. And so add this to your notes. All matter is composed of atoms. So we have an example here of rubbing alcohol. And you can see that if we were able to look inside of it, it would really look like this. It would be a bunch of different atoms that are bonded together that actually make the product that you're holding. So all matter is composed of atoms. There are three states of matter. You're very familiar with these, and so write down the three states of matter. And you want to go ahead and make you a little diagram that looks just like this. You have solid, liquids, and gases, and you're probably used to seeing these little drawings right here that simulate what a solid and liquid gas looks like. So on your notes right here, see, I wrote down solid, liquid, gas, and I drew the little picture. And just know that underneath each one of these, I'm going to give you a few notes to write down on the next couple screens, right? So underneath solid, you're going to write down a few things, liquid a few things, and gas a few things. All right, so draw that, and then let's write some notes down about solid, liquid, and gas. So here's your notes for about a solid. In a solid, the atoms are in a fixed location. And that's why we draw the picture the way we do, where we say, hey, look, they're all kind of like stuck together, right? So the atoms are in a fixed location. They have a fixed volume and shape. So whatever the shape and volume of your solid is, it's that shape. It's not going to change. And some examples of solids would be things like ice and diamond, quartz, iron. These are all good examples of things that are solid, and they're the shape that they are. There are two specific types of solids that we should know about. The first type is what's called a crystalline solid. All right, and these are ones that are in repeating order. So they repeat themselves. So think of like a crystal. It makes sense, right? Think of looking at salt or sugar. If you've ever been in a cave and you've seen a crystal and it looks like it has a pattern that repeats, that is what a crystalline is. So the atoms are in geometric patterns with repeating order. The other is amorphous solids, and these do not have order. All right, so here's some examples right here that you can jot down. Examples of crystallines would be like salt and diamonds. Examples of amorphous are what most solids that we think of, and those would be things like glass and plastic and rubber. These are all also solids, but they have no like repeating pattern. Liquids. Oh, sorry, before we say liquids, here's a picture of a salt cube, right? And you can just see that it looks like it has a repeating pattern. All right, nothing to draw right there, just showing you the picture. All right, now let's talk about liquids. All right, so liquids, the atoms are a little more free to move, and so that's why in the picture we say, hey, they're a little bit more spaced out. All right, so for the notes underneath, we say that they're free to move. They do have a fixed volume, but liquids take the shape of their container. So whatever you pour your liquid into, it's going to take the shape of this container. If I poured it into another cup, it's going to take the shape of another container, and that would be a liquid. Liquids include things like water, gas, mercury, which is on the periodic table, but mercury is a metal that is also a liquid. These are all examples of they could take the shape of their container. The last one, gas. So on gas, the atoms are really spaced out, all right, so they're really moving freely. And so the atoms are separated by large distances and free to move. Write down that gases are compressible. And gases always assume the shape and volume of their containers. So just like liquids, whatever you put a gas into, it's going to take the shape of that container, but it's also going to have the volume of that container. And of course, just think of all the gases on the periodic table. There's a couple, oxygen and helium, but also it can be a gas if it's a compound like carbon dioxide. So those are our solid, liquids, and gases. Here's a picture real quick of what we mean by compressible. You don't have to draw this, but solids, you can't compress that. But a gas, you could squash it down. So that's why gases go into canisters, and we have aerosols and things like that. All right, now what you want to do is you want to draw this little table that you see here. So you can see that I've drawn it in my notes. You would want to draw it also, and just know that each one of these boxes on here, like where it says pure substances and mixtures and elements and compounds, you're going to add a little note. So you can see that on mine that I'm saying, hey, you're going to put some notes here. You're going to put some notes under each one of these boxes. So just know you're going to jot down some notes. So here we have what I call the matter pyramid. And so the matter pyramid starts with matter, and matter can be broken down into two different categories. And those categories can be broken down into two different categories, and each has an example. As soon as you have that drawn, let's take the notes real quickly. And so again, we said that matter, back here on the top, matter was anything that has mass and takes up space. We've already written that down. Let's talk about a pure substance. So a pure substance is composed of only one type of atom. So underneath pure substance, just write down, it's composed of only one type of atom. And then you see that pure substance breaks down into two different categories. So let's jot down quickly underneath that. So an element cannot be broken down into simpler substances. We've been dealing with this for several weeks. And examples of elements would be anything on the periodic table. Here's an example of helium. Inside your party balloons at your birthday party, helium is a pure substance. It's only helium in there. That's why it floats. It's lighter than the air. You don't have to draw that. It's just an example. However, a compound is two or more elements. This is what we did last week with the Mollymods. So you were making compounds as you put them together, and you got to see different color Mollymods stuck together, and that's what we call a compound. Compounds are more common, and examples of compounds would be, water, salt, sugar. These are all easy, common examples of compounds. All right, now we've completed this side. You should have some notes written down about pure substances, elements, and compounds. Now let's go over to the other side and talk about a mixture and the difference between the two types of mixtures. So a mixture right here, write this down. A mixture is composed of different substances simply mixed together. It's exactly what it sounds like. I mixed two things together. I made a mixture. The two types of mixtures are what are called homogeneous and heterogeneous, or sometimes you hear homogeneous and heterogeneous. It's kind of pronounced both ways, so whichever you prefer is fine. But homogeneous mixtures, if you follow my little pink arrow right here, means you cannot see the difference. So like when these things are mixed together, it looks like just one thing. So an example for that would be like sweet tea. If I had sweet tea in one cup and unsweet tea in the other cup, nobody would know the difference, except the sweet tea has sugar mixed into it. You just can't see it. So that means you cannot see the difference. However, heterogeneous or heterogeneous, however you'd like to say that, mixture, you can see the different parts. So if I took nuts and bolts and mixed them together, I could see the different nuts and bolts. Or if I took trail mix and I bought trail mix at the store, you can see the peanuts separate from the M&Ms, separate from the raisins. That's an example of a homogeneous or heterogeneous mixture. You can see the different parts. So again, on your paper right here, you should now have this side filled in. Mixtures, what they are, what a homogeneous mixture is, something like tea, what a heterogeneous mixture is. Here's another example. Things like oil and water, they separate out. Those are your notes for this week. Please take a picture and post them under the virtual assignment for week 15. All right, everybody, have a good one.